simulation of memory block transfer program using Keil software. Before watching this video, watch the video for explanation of memory block transfer program. You can press the I button or the link of that video is given in description box. Click on Keil icon. This window will be open. Click on New Project and then you can create a folder. So where you want to store this project, you can create a new folder. So right click, New. And I am giving name to this folder as one memory block. And in this folder, we'll store this project file with same name, one memory block. So click on Save. Now you have to select the particular microcontroller. So you can select the companies of microcontroller. So here the manufacturer company names are given. So Philips NXP I am selecting. I am selecting here 89C51RD2XX. So here you can observe the specifications of this IC. Click on OK. So here copy startup.A51. Click here No. So in project window, you can see here project name and the target 1 and source group. Now we'll create a .asm file. Click on File, click on New, and first we'll save this file in the same project folder, one memory block. So you can give any name, memory B, any name you can give, but save it with .asm extension. Click on Save. Now this file, ASM file, we should include in the source group. So for that, right click on this source group and click on Add Existing File to Group. So click here and this .asm file you have to select. Click on Add, click on Close. So .asm file is now included in this particular source group. Now you can type your program here. Program is written here. The program will be stored at memory location 000H. So org 000H is written. Then the source memory block address is 10H. So R0 is used as a pointer to source memory block. So 10H is stored in R0. The destination memory block address is 30H. So 30H is stored in register R1. R1 is used as a pointer to destination memory block. So total data of 10 memory location we want to transfer from source memory to destination. So counter R7 is initialized with 0AH, that is 10 in decimal. So here R0 is pointer for source memory location. So indirect addressing mode is used. So we are reading a data from first memory location and that data is stored in accumulator. The accumulator data is stored at a destination memory location in next instruction. So here we are reading a data from source memory location and then that data is stored at destination memory location. So after copying data of first memory location, we are incrementing this pointer location. So 00H address is incremented by 1 and 01H address is incremented by 1. That is 00H is the address of register R0. So here we are incrementing contents of R0. 01H is address of register R1. So we are incrementing contents of register R1. So after that, we are decrementing here counter by 1 and checking whether counter is 0 or not. So if it is not 0, it will jump back to this location, back label. So it will continue reading a data from source and sending it to destination. So data of 10 memory location will be transferred from source memory to destination. To end this program, here sjump instruction is used. So it will continuously execute this instruction, and to end the kill program you have to write here end instruction. So for detailed explanation of this program, you can watch a video of memory block transfer. First watch that video and then you can simulate this. So program is type here, save the program and build the program. Here zero error and zero warning. So we can debug this program. Click on debug, click on start debug session. You'll observe this message evaluation mode running with code size limit 2K. So because this is evaluation version, you can have a limit of program code as 2 kilobyte. So click on OK. Here this debug window is open, and we will execute this program stepwise, and we have to observe the data memory. So we want to transfer a memory block from address 10H to 30H. So these addresses are in data memory. So we have to observe a data memory location. So for that you can observe here memory. So first click on view and then click on memory windows. So 4 memory windows you can use here. So I'll click on memory. So here you can observe memory 1 window. Now here C letter is used. So letter D is used for data memory. So type here D colon and then address. So we want to find the data from address 10H. So I am typing here 10H. So this is address 01, 08, 09, 0A, 0B, 0C, like that, and you can find here data memory. If you click on this, right click on this, you can find the address modify memory at 0x12. So here if I right click modify memory at D09. So you can check address 10H. This address is 10H. So we'll store some data at this memory location. So click on modify memory at 10H. So here any data you can store. So I'm storing here 54. That will be stored in hex. So here you can see, right click on this modify data, suppose 12. So that will be stored at 11H. The next memory location data you can modify 02H I am storing. Then here you can store a data 80H. So 10 memory location data you can modify 01. So others I will keep 00. You can change this data. So this we want to send this data at location 30H. So where you will find 30H, that will see. This location is 30H. So data will start storing from 30H. So after execution of this program one time, 36H should be stored at this memory location 30H. So we'll execute this program step by step. For that, you have to press F11. So first instruction is executed. In R0, 10H is stored. Here you can observe 10H is stored in R0. Then F11 I am pressing. 30H is stored in R1. 0AH is stored in R7. Now the data at this address, that means at address 10S36, must be stored in accumulator. So we'll see that. So 36H is stored in accumulator. Now it should be stored at memory location 30. So press F11. You can observe here data is stored at this 30. So all this data should be stored from address 30 here. So I am continuously pressing F11 and you can observe the data is transferred from this memory locations to this memory location. So again continuously I am pressing. You can observe the shift of data here. Other numbers are 0. So here you can observe this data. This data is transferred here at this memory location. So this is how you can simulate memory block transfer program.